This is part 26 of my preparation for NSE4 exam, and we are talking about IPsec setup. The IPsec setup consists of 4 stages. The first one is VPN setup, second is authentication, third is policy and routing, and fourth is review settings. In phase 1, extended authentication. Phase 1 extended authentication supports 2 types of authentication. First one is PSK, pre-shared key, and second is signature-based authentication. The XAUTH extension sometimes is called phase 1.5, and it forces remote users to authenticate additionally with their credentials. So, additional authentication packets are exchanged if you enable extended authentication. When you set remote gateway as dial-up user, FortiGate acts as the authentication server. XAUTH section shows authentication server. XAUTH section consists of following options. First one is PAP server. PAP server is password authentication protocol server, and PAP provides only basic functionality. Second option is CHAP or CHAP server. CHAP is Challenge Handshake Authentication Protocol, and CHAP server periodically verifies the identity of the client. Third option is auto server, and the fourth option is disabled. Auto server automatically detects the authentication protocol used by client. When you configure a new user group, matching is performed. There are 2 options. First, inherit from policy. Second, choose. Choose allows you to select one of the user groups available on FortiGate, and you must configure a separate dial-up VPN, virtual private network, for every group of users that require a different network access policy. And inherit from the policy works like FortiGate authenticates users based on their matching IPsec policy, and as a result, the configuration for controlling network access. By configuring multiple policies for different user groups instead of configuring multiple tunnels for different user groups. The inherit from policy option follows similar authentication approach used by SSL VPN remote users. When remote gateway is set to static IP address or dynamic DNS, FortiGate acts as a client, and XAUTH section shows client option as type. You can then set the credentials that FortiGate uses to authenticate against the remote peer through XAUTH. So we finished part 1, phase 1, and we go to phase 2 in IPsec. VPN. How it works. Phase 2 negotiates security parameters for two unidirectional IPsec CAs, security associations, over the secure channel established during phase 1. So it is a secure channel which is protected by phase 1 IPsec, Internet Key Exchange Security Association. ESP, encapsulating security payload, uses IPsec SA security associations to encrypt and decrypt the traffic exchanged between sites. Phase 2 doesn't end when ESP, encapsulating security payload, begins. When IPsec security associations are about to expire, it renegotiates. Optionally, if you enable perfect forward secrecy for each time phase 2 expires, FortiGate uses DH Diffie-Hellman to recalculate new secret keys, making it much harder than for attacker to crack the tunnel. Each phase 1 can have multiple phases too. For example, when you use different encryption keys for each subnet whose traffic is crossing the tunnel. So it uses high security subnets can have stronger ESP, encapsulated security payload. How does FortiGate select phase 2 to use? It chooses by checking which phase 2 selector or quick mode selector matches the traffic. Phase 2 selectors. In phase 2, you must define the encryption domain or interesting traffic for your IPsec tunnel. The encryption domain refers to the traffic that you want to protect with IPsec, and it is determined by your path to selector configuration. Phase 2 determines the encryption domain. You can configure multiple domains, multiple selectors for granular control over traffic. If traffic doesn't match selector, it is dropped. In point-to-point VPNs, selectors must match. The source on one FortiGate is the destination setting on the other. You select which selector to use by setting. First, local address and remote address. Second, setting protocol number. By default, it's set to all. And by setting up local port and remote port, you can define IPv4 or IPv6 addresses using different address scopes. When selecting named address or named IPv6 domain, FortiGate allows you to select IPv4 or IPv6, Internet Protocol version 4 or version 6. And firewall, you can choose IPv4 or IPv6 firewall address object, respectively, configuring in the system. Local or remote port as a selector. It's also set to all by default. This applies only to port-based traffic, such as TCP, Transport Control Protocol, or UDP, User Datagram Protocol. Note: after the traffic is dropped before entering the IPsec tunnel, if the traffic does not match any of the phase 2 selectors configured, then it drops. For this reason, usually it's more intuitive to filter traffic with firewall policies. So if you don't want to use phase 2 selector with both local and remote addresses set to any subnet, and then use firewall policies to control which traffic is accepted on the IPsec tunnel. In phase 2, selector network parameters on both peers must match if the tunnel is point-to-point. That is when the remote gateway is not set to dial-up user. Phase 2 proposal. Phase 2 proposal determines the encryption algorithms. You can configure multiple proposals for added flexibility, and it impacts performance and hardware offloading. You can enable replay detection to protect against ESP encapsulating security payload replay attacks. There is a local setting for that. A phase 2 selector configure one or two or more than two proposals. A phase 2 proposal defines the algorithms supported by the peer for encrypting and decrypting the data over the tunnel. You can configure multiple proposals to offer more options to the remote peer when negotiating the IPsec security associations. Like in phase 1, you need to select a combination of encryption and authentication algorithms. Some algorithms are considered to be more secure than others. So make sure to select the algorithm that confirms with your security policy. Note that the selection of the algorithm has the direct impact on FortiGate IPsec performance. For example, one of the most prominent types of encryption is triple DES. 3DES stands for Data Encryption Standard, and triple DES operates in 3 steps: encrypt, then decrypt, and then encrypt again. So 3DS is known to be secure, but at the same time it has much more resource-intensive encryption algorithm rather than DES, Data Encryption Standard, or as AES, Advanced Encryption Standard. So it means that your IPsec throughput could be negatively impacted if you choose triple DES. Also note, if you select null as the encryption algorithm, then traffic is not encrypted. Some encryption algorithms such as CHA like CHA-20, Poly 1305 are not supported for hardware offload. That is, if you have a FortiGate device that contains network processor and P units that you can achieve higher IPsec performance if you select an algorithm that is supported for IPsec offload by your NP network processor unit model. AES Advanced Encryption Standard or DES Data Encryption Standard. To see all options available, you can go to docs.fortinet.com. And when configuring the Phase 2 proposal, you can select Enable Replay Detection to detect after-play attacks, and this is a local setting and therefore it is not included as a part of the proposal presented by the peer during Phase 2 negotiation. Also, if you enable perfect forward secrecy, FortiGate uses Diffie-Hellman to enhance security during the negotiation of IPsec SAs. IPsec SAs, security associations, is the relationship between two or more entities that describes how the entities will use security services to communicate securely. IPsec SAs, security associations, periodically renegotiated to improve security. It depends on the key lifetime settings configured on Phase 2 proposal. Thank you. See you in the next video.